Next, our example 8.1.4 saying that two circles intersect each other at the points A and B through a point P. On one of the two circles, two straight lines PAC and PBD are drawn, intersecting the other circles again at C and D respectively, so that CD is parallel to the tangent at P to the circle on which it lies. So this is our example 8.1.4. This is the diagram. So in here you see two circles. This is the smaller circle, it is the circle on the left, and the bigger circle, this is the circle on the right. So these two circles, they intersect each other at points A and B. Now point P, this point P is on the left circle, and through this point two lines are drawn. Through this point two lines are drawn which intersect the circle on the right at C and D respectively. So therefore, given two circles intersect each other at point A and B, PA and PB, this is PA and PB when extended, intersect the circle on the right at C and D respectively. I have to prove that this is a tangent. Yes, this is a tangent drawn at point P. Yes, this is a tangent drawn at point P to the left circle. This is a tangent. I have to prove that this tangent EF is parallel to CD. So these two circles, they intersect each other at point A and B. PAC and PBD are two lines drawn from point P. PAC and PBD are two lines drawn from point P, and these two lines, they intersect the circle on the right and at C and D respectively. And at point P, a tangent is drawn, EF, a tangent is drawn at point P. So this is our two circles intersect each other at points A and B. PA and PB when extended intersect the circle on the right at the 2 points C and D respectively. PA and PB when extended intersect the circle on the right at C and D respectively. AB and CD are joined, and a tangent at the point P is drawn to the circle on the left. AB and CD are joined. Yes, AB and CD are joined, and a tangent at the point P is drawn to the circle on the left. I have to prove that EF is parallel to CD. So now in here, first of all, what I will do, you see this angle BPF or FPB, this angle will be is equals to this angle PAB, angle in the alternate segment. Yes, angle in the alternate segment. This angle will be is equals to this angle. Next, you see this angle PAB plus BAC. This angle plus this angle. Yes, this one PAB plus BAC. These two angles, if I plus 2, then I will get 180 degree, because these two angles forms a linear pair. So this angle plus this angle, it will be 180 degree. Next, you can see that this quadrilateral ABDC, this quadrilateral is a cyclic quadrilateral. ABDC is a cyclic quadrilateral, and we know that sum of the opposite angles in a cyclic quadrilateral is 180 degree. So therefore, BAC plus BDC, these two angles will be is equals to, their sum will be is equals to 180 degree. So you see, first of all, I got that this angle is equal to this angle, then this angle plus this angle is equals to 180 degree, then again this angle plus this angle is equals to 180 degree. Okay, so next you see this one, PAB plus BAC is equals to 180 degree. PAB plus BAC, BAC 180 degree. Then next again BAC plus BDC, these two angles is equals to 180 degree. BAC plus BDC is equals to 180 degree. ABDC is a cyclic quadrilateral. So from these two, what I got, right hand side is equal to right hand side, so therefore left hand side equal become. So PAB plus BAC is equals to BAC plus BDC it became. Now BAC you can cut it. So ultimately I got PAB is equals to BDC. Yes, ultimately I got PAB is equals to BDC. Let's see. PAB is equals to BDC. Okay, this angle is equals to this angle I got. Next you see, this angle is equal to this angle. Yes, angle in the alternate segment. Already I have said this angle is equal to this angle. And now what I have got, this angle is equal to this angle. So therefore what I can say, this is equal to this and this is equal to this. So therefore I can say that FPB is equals to BDC. This angle will be is equals to this one. Yes, and these two angles are equal, and these two angles are what? They are alternate angles. Yes, you see Z. These two angles are alternate angles and they are equal. So therefore I can say that EF is parallel to CD. This is our proved. Next example 8.1.5, we will do it in the next video. Now I am going to example 8.1.6. So example 8.1.6 here, you see A, B and C are any 3 points on the circle if the bisector of BAC cuts BC at the point D and the tangent to the circle at A meets BC at O when extended, then prove that AO is equals to OD. So this is our A, B, C are any 3 points. Yes, A, B, C are any 3 points on a circle if the bisector of angle BAC, this is angle BAC, yes, bisector of angle BAC cuts BC at point D. So AD is the bisector. AD is the bisector of BAC. That means this angle will be is equals to this angle here. So, and the tangent to the circle at A, okay, this is the tangent to the circle at A meets BC at O. Tangent to the circle at A meets BC, okay, meets BC at O. That means BC is extended. Yes, BC when extended, then this tangent and BC extended, they intersect at point O. So and the tangent to the circle at A, you see the sentence, the tangent to the circle at A meets BC at O when extended, meets BC at O when BC is extended. Then prove that AO is equals to OD. I have to prove that AO is equals to OD. Okay, AO is equals to OD I have to prove. So this is our given. A, B, C are 3 points on the circle, joining the points pairwise. These sentences I have written from your book only. Joining the points pairwise, the triangle ABC is formed. The tangent to the circle at A and BC when extended meet at O. The bisector of BAC cuts BC at D. Prove that AO is equals to OD. Now proof. So in here you see OAB is equal to ACB. OAB is equals to ACB. Okay, OAB is equals to ACB. Yes, OAB, you see here, OAB, this angle will be is equals to ACB. Yes, it will become angle in the alternate segment. Yes, theorem 8.1.1, or you can say theorem 8.1.1. Let's see theorem 8.1.1 here. Yes, this one, angle in the alternate segment theorem. Yes, the angles made by tangent to the circle with any chord through the point of contact are respectively equal to the angles in the alternate segment of the circle. Angle in the alternate segment. Yes, theorem 8.1.1 or angle in the alternate segment. This angle OAB is equals to ACB. Next you see here ODA. Okay, ODA is equals to, okay, you see this is our exterior angle property. For this triangle ADC, this angle, you see, this angle will be is equals to this angle plus this angle. This is our exterior angle property for this triangle ADC. This angle will be is equals to this angle plus this angle. So ODA is equals to ACD plus CAD, our exterior angle property. Now you see here, I have already said that this angle OAB, this angle is equal to this one. Yes, ACB, angle in the alternate segment. So in here you see, instead of writing ACD, I can write CA. Okay, see, instead of writing ACD, I can write here OAB. Instead of writing ACD, I can write here OAB. Yes, see here, first of all I am saying OAB, this angle is equals to this angle. Yes, angle in the alternate segment, and then this angle is equal to this angle plus this angle, exterior angle property. Now since this one angle is equal to this one, so therefore instead of saying this angle equal to this angle plus this angle, I can say that this angle is equal to this angle plus this one. Done. CAD, that is CAD is equal to, instead of writing ACD, I can write OAB. Finished. Next you see here again, instead of writing CAD, I can write here BAD. Okay, see, instead of writing CAD here, I can write BAD, because in here you see AD is the bisector. See, angle BAC. AD is the bisector of angle BAC. Yes, AD is the bisector of angle BAC. So instead of writing this angle is equal to this angle BAC, AD bisect doing, so this angle is equal to this angle. So now instead of writing this angle plus this angle, I can say that this angle plus this angle. Instead of writing CAD, I can say BAD plus OAB, since AD bisect BAC. Now in here you see BAD plus OAB, this angle plus this angle, what became our? I got OAD, I will get OAD. Yes, so therefore I got that ODA is equals to OAD, I got. Yes, ODA, this angle is equals to this whole angle I got. Yes, this angle is equals to this angle. Now in this triangle, if you see nicely, ODA, this angle is equal to this angle. So therefore these two sides will be equal. OA will be is equals to OD. This is our triangle property. There you have already learnt in lower classes. So therefore in here what is going on? First of all, in here you see, see here, I am drawing the diagram one more time. This is our circle there. So at point A there is a tangent. AC is joined. This one OB is a point. AB is joined. This AD is the bisector of angle BAC. I have to prove that OA is equal to OB. I have to prove. Yes, OA is equals to OB. I have to prove. So now in here you see this angle, will be equal to this one. Yes, angle in the alternate segment. Then you see this angle, this is exterior angle property for triangle ADC. This angle will be is equals to this angle plus this angle. Yes, exterior angle property. Now you see, since this angle is equal to this angle, so instead of writing this angle BDA is equal to DCA plus DAC, instead of writing that, I can say that BDA, or instead of saying BDA, I can say ODA. Yes, ODA is equals to, I can write that BAC, this angle, plus this angle OAB, because this angle is equal to this angle in the alternate segment. So this angle is equal to this angle. Instead of saying this angle, I can say this angle equal to this angle plus this angle. Now you see AD is the bisector of angle BAC. So this angle will be is equals to this one. Yes, this angle will be is equals to this one. AD bisecting angle BAC. So this angle will be is equals to this one. So therefore, I can write now ODA, this angle is equals to, instead of saying this angle plus this angle, I can say that this angle is equal to this angle plus this angle. These two angles if we plus do, I will get OAD. So I got this angle is equals to this angle. I got this whole angle. This angle is equals to this whole angle I got. Now in triangle AOD, if you see nicely, these two angles are equal. This one is equal to this one. These two angles are equal. So therefore, the sides opposite to them will be also equal. So therefore, OD is equal to OA become. This is our proved. This much only our example 8.1.6. Next you see there was a question which was not given. Exercise 8.1 question number 3. Exercise 8.1 question number 3. It was not given in class. Two circles touch each other internally at a point P if a chord AB of the larger circle to a tangent to the smaller circle at a point C. Then prove that CP is the bisector of angle APB. So this one our diagram. This will be our diagram here. So two circles touch internally at point A. These two circles are there. These two circles touch internally at point P. AB is a tangent at point C. AB is a tangent at point C. AB is a tangent at point C. To prove that angle CPA is equals to angle CPB. To prove that CP is the bisector of angle APB. CP is the bisector of angle APB. Okay, CP is the bisector. I have to prove that this angle is equals to this angle. I have to prove these two angles. I have to prove that they are equal. So now how will I do it? So there is a construction, you see, a tangent XY is drawn at point P, CD is joined. A tangent XY is drawn at point P and CD is joined. These two are the construction. Now you see proof. Since XY is a tangent at point P, so therefore APX is equals to ABP, angle in the alternate segment. Okay, APX, yes, this angle will be is equals to angle in the alternate segment ABP. This angle, see, this angle will be is equals to this angle. This is our angle in the alternate segment, equation 1. Next in here you see angle APC is equals to CDP. Angle APC is equals to our angle CDP. Okay, so here is a small mistake. Actually it is not APC. This will be CPX. Okay, CPX. This will be CPX. Okay, so CPX, this is the angle, this whole angle CPX. This angle will be is equals to, you see, for this circle CPX, CP is the chord, CPX, this whole angle will be is equals to this one, angle in the alternate segment, CDP. CPX, not APC, it will be CPX is equals to CDP. So this is our equation 1. APX is equals to APX is equals to ABP. Okay, APX for the big circle, APX is equals to ABP. This is our equation 1. And then for the smaller circle, CPX is equals to CDP. This is equation 2. Now what I will do, equation 2 minus 1. So APC minus, this will be CPX, okay, not APX, it will be CPX. Sorry, this is correct, APX, this is APC, not, this will be CPX, okay. So CPX minus APX, see, CPX, this whole angle minus APX, I will get this angle is equals to CDP minus ABP, CDP minus ADP, CDP minus ABP, this angle minus this angle. So now you see CPX minus APX, I will get APC, yes, or CPA. See, CPA is, these two will remain like that only, CDP minus ABP, CDP minus ABP, these two will remain like that. So next our, see, CPA is equals to CDP minus CBD, instead of ABP, I can write it as CBD, okay. Now my same angle only, either you can say this angle one, either you can say ABP or CBD, yes. So instead of saying ABP, now I will call it CBD, and this is our equation 3. Now in triangle CBD, this one you see CDP is equals to ABD plus BCD, CDP in triangle, you see, in this small triangle CBD, this angle will be is equals to this angle plus this angle, this is our exterior angle property, yes. CDP will be is equals to CBD plus BCD, exterior angle property. Now what I will do, this CBD I will bring this side, so CDP minus CBD is equals to BCD, equation 4, okay. So in here what I got, CDP minus CBD is equals to BCD, okay. This angle one I this angle I took it out, yes, this angle I took it out, BCD, this angle I got, BCD is equals to what, BCD is equals to CDP minus CBD. Next you see, since AB is the tangent at C, since AB is the tangent at C, for this drawn to this circle, this small circle, yes. So therefore in here you see, this is the tangent, yes, this is the tangent, this angle for this small circle, you see, this is the tangent, this is CD is the chord. So this angle will be is equals to angle in the alternate segment, okay, angle in the alternate segment, this angle will be is equals to, you see, this angle in the alternate segment, yes. BCD will be is equals to CPD, BCD is equals to CPD, this angle will be is equals to this angle in the alternate segment. Once more, what I have to prove here, I have to prove that CP is the bisector of APB, CP is the bisector of APB, that means this angle is equals to this angle, I have to prove here. So now I got that this angle is equals to this angle in the alternate segment. This is our equation 5, yes, this is our equation 5 here. So therefore you see what I got, first of all I got that this angle BCD is equals to, I got CDP minus CBD, this angle minus this angle is equals to this angle minus this angle, and this angle is equals to this angle I got, yes. See, BCD is equals to CDP minus CBD and BCD is equals to CPD I got, done. So this is our equation 5 and this is our equation 4. Next what I will do, from 1, 2, 3, 4 I can say that CPA is equals to CPD, okay. From 3, 4 and 5 I can say that CPA equals to CPD, okay. From 3, 4 and 5, 3 is our CPA is equals to CDP minus CBD, CPA, this angle is equals to, I got that CDP minus CBD I got. Okay, so you see this angle is equals to this angle minus this angle I got. Yes, this angle is equals to this angle minus this angle I got. And then next again you see this angle is equals to, I got this angle minus this angle. Okay, first of all I got that this angle is equals to this angle minus this angle, and then I got that this angle is equals to this angle by this angle, minus this angle from exterior angle property. Yes, and then I got that this angle is equals to this angle. See, first of all this angle, this one is equals to this angle minus this angle, that one our equation 3. Then I got by exterior angle property, this angle is equals to this angle minus this angle. Yes, this is equal to this minus this, again this is equal to also this minus this, and this angle is equal to this one, angle in the alternate segment. So therefore from 3, 4 and 5 these two angles will be equal. This is our proved. Okay, so from the beginning I am saying, you see, for the bigger circle, AP is the chord and XY is a tangent drawn to this circle at point P, and CP is the chord. So therefore this angle will be is equals to this one. And then again for this smaller circle, again you see this whole angle will be is equals to this one, angle in the alternate segment. This big angle minus this one I will do, ultimately I will get this angle. So this angle is equals to this angle minus this angle I got. That is equation 3. Next again by exterior angle property I can say that this angle is equal to this angle equal to this plus this. Yes, from there I will find out this angle. So this angle I will get that this minus this angle will be is equal to this minus this, CDP minus CBD. Okay, so first of all I got that this angle is equal to this minus this, then again this angle equal to this minus this, and then you can say that this angle is equal to this one, angle in the alternate segment, this one CPD. Yes, BCD equal to CPD, angle in the alternate segment. So this is equal to this minus this is equal to this minus this, and this is equal to this. Therefore from 3, 4 and 5 these two angles will be equal. So this is our exercise 8.1 question number 3. It was not given in class. There's a small mistake, you can correct it up. Next I will go to example 8.2.1. Example 8.2.1. This is our example 8.2.1. So now in here you see, in a triangle ABC, AC equal to 4.8 centimeter and AB equal to 7.2 centimeter. The internal bisector of angle A intersect BC at X. BX is equals to 1.5. Find BC. So this is, you see, AX is the internal bisector. Yes, AX is the internal bisector of angle A, and AX intersect BC at X. So these things are given here. I have to find BC. Okay, so since AX is the internal bisector of angle A, so therefore I can say that AB by AC, yes, this is our theorem, AB by AC is equals to BX by XC. AB by AC is equal to BX by XC. Put the values and you solve it. So XC is equals to, you will get 1 centimeter. XC is equals to 1 centimeter. So BC will be equal to BX plus XC, 1.5 plus 1. Ultimately BC you will get 2.5 centimeter. This much only, example 8.2.1. Next our example 8.2.2. This is our example 8.2.2. AD is a median of triangle ABC, and the internal bisectors of angle ADB and ADC intersect AB and AC at E and F respectively, so that EF is parallel to BC. Okay, AD is a median of triangle ABC, and the internal bisectors of angle ADB and angle ADC intersect AB and AC at E and F respectively. I have to show that EF is parallel to BC. This is our diagram. So ABC is a triangle, AD is the median, AB is the median. The internal bisector of angle ADB, ED ED is the internal bisector of angle ADB, and DF is the internal bisector of angle ADC. These two internal bisectors intersect AB and AC at E and F respectively. To prove that EF is parallel to BC, I have to prove that EF is parallel to BC. So proof, since DE is the internal bisector of angle ADB, in this triangle we will see, no need to look the other half, in this triangle we will see, since DE is the internal bisector of angle ABD, so therefore I can say that I can say that AD by BD is equals to AE by BE. Yes, AE by BE. This is from our theorem. Yes, this is the internal bisector, so AD by BD is equal to AD by BE, I can say. Yes, so this will be our equation 1 here. I have to prove that EF is parallel to BC. Okay. Next, again you see, since DF, in this triangle we will see, since DF is the internal bisector of angle ADC, so therefore I can say that AD by DC is equal to AF by FC, I can say. AF by FC, I can say. Yes, AF by FC is equal to AD by DC. Yes, AD by DC. Next, again in here you see, AD is a median given. Yes, AD is the median of triangle ABC. AD is the median given. So therefore here D will be the midpoint of BC. Yes, AD is the median given, so D will be the midpoint of BC. So now in here you see, now AF by FC is equals to our AD by DC, or AD by DC equal to AF by FC, whatever you say. So AF by FC is equals to AD by DC. Now in here you see, instead of saying DC, I can say AF by FC is equals to AD by BD, because D is the midpoint, BD will be equal to DC. So therefore instead of saying AF by FC is equal to AD by DC, I can say AF by FC is equals to AD by BD. Yes, AF by FC is equals to, I can say AD by BD. Now AD by BD, what I have said already, you see, AD by BD, what I have said, AE by EB I have said, AD by BD is equal to AE by EB I have said, and then now what I got that AF by FC is equal to AD by BD. Yes, AD by BD equal to AE by BE, and again in here I got AF by FC is equals to AD by BD. AD by BD, you see, AD by BD, and in here also AD by BD, right hand side equal there, so left hand side equal become, so therefore I got that AF by FC is equal to AE by EB. What I got here, see, AF by FC is equals to AE by BE. Yes, this by this equal to this by this, so therefore I can say that EF is parallel to BC. AF by FC is equals to AE by EB, so therefore EF is parallel to BC. This one by theorem you have already got in general mathematics.